Hey everyone, it's Justin here. What are we talking about today? I'm sorry. It's been a long day. It all started when I made this really irrational purchase. So I bought this new flat screen TV, right? Really big one. Like, this thing is exponentially larger than my old TV. It's 75 inches to be exact. It's big. So I figure, oh, this will be great for me to watch like action movies and sports on. But then I bring it back home and I realize it's so big that I don't have the manpower to bring it up the stairs into my apartment. So I call a couple of buddies, bring it upstairs, and then I realize it's too big for my TV stand. I have no base to set it on. So I leave it in the box and now it's just sitting there on my floor, taking up space in my tiny 600 square foot apartment. The root of this issue is that I did not think this purchase through. But now if I ever start an action movie, I do have a really nice TV to watch myself on. Now, I know what you're probably thinking. Justin, you're here to teach us algebra, not talk about your personal problems. And I get that, but did you notice anything mathy about the story I just told you? Maybe some everyday words that also have mathematical significance. Words like power, exponentially, base, root, square, and irrational. All of these words are probably familiar to you, but you may not yet realize their mathematical significance. In this video, we're going to get a brief introduction to the next unit of this course, exponents and radicals, as well as discuss the real-world application of its concepts. By the end of this video, you should be able to explain how some of the topics covered in this unit connect to everyday life. You might even be able to think of your own scenario where one of these concepts could be used. Let's go! This new unit we're starting can be broken up into four main parts: rules of exponents, roots basics, rational and irrational numbers, and simplifying radicals. As you probably already know, an exponential expression includes a base number raised to some power, or exponent. And that power tells you how many times to multiply the base number by itself. This expression is pronounced x to the power of 2. Exponents are frequently used with scales of measurement in science, or they're used to describe really, really large or really, really small numbers using scientific notation. Like, say you wanted to describe how many bacteria were in a petri dish, and you wanted to write out that there were 8 quadrillion bacteria in there. You could write that number as 8, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, but that's a lot of zeros. Instead, you could write that same number using scientific notation. 8 quadrillion in scientific notation is just 8 times 10 to the 15th power. Now that's a lot neater, right? And this also works for really small numbers too. Like, you could write 0.000000000000005 as 5 times 10 to the negative 14th power. Pay close attention to our lesson on negative exponents in this unit to find out how that works. Exponents are also super important later in math when we start talking about exponential growth and decay. Turns out lots of real-world scenarios can be modeled using exponential functions, like modeling how money might grow in a bank account, or how many likes a viral social media post might get over time. Exponents aren't the only tools we're needing in our tool belt, though. You'll see roots and exponents go hand in hand. You'll learn more about their relationship as you go through this unit, but for now, just know that roots are in a lot of mathematical equations that we need to solve everyday problems. Like trying to figure out the dimensions of your new 800 square foot apartment, roots will give you a hand there. Trying to figure out what size ladder you need in order to reach the roof to hang up those holiday decorations. You're gonna need roots to be able to solve the Pythagorean theorem to figure out what size ladder you need. Or you could just shimmy up the gutter with a tape measurement and hope for the best. At the end of this unit, we're going to go over rational versus irrational numbers and radicals. Both of these concepts are found and used just about everywhere. Irrational numbers are just numbers that go on and on forever without ever repeating. The irrational number pi, the number, not the food, is used to solve the circumference and area of any circle. That's right. If you want to figure out the area of your pie tin, you're going to need pi. Oh, okay, now I'm getting hungry. Let's move on. One of the most famous irrational numbers in nature, the golden ratio, is irrational and features a radical. It can be written as 1 plus the square root of 5 over 2. The golden ratio shows up everywhere in nature, from the spiral of a snail shell to the pattern of sunflower seeds at the center of a sunflower, to even the proportions of the perfect human face. I myself like to think I have a golden ratio face. So those are all the main topics we're going to be covering in this unit. What's it got to do with my TV? Well, for starters, if I had known the length of my new TV I bought earlier today, I could have recognized before I even bought it that it wouldn't fit on my TV stand. You see, TV measurements provide the diagonal distance from one corner to the other on the screen, not the length. But I can use exponents and roots to find the length using the Pythagorean theorem. When I buy my new TV stand, I'm gonna need to take its measurements to see how much space it'll take up in my tiny apartment. Area is measured in square feet, so that's another exponent there. And let's say I'm gonna need to buy a new round coffee table to match that new TV stand. I'm gonna need that irrational number pi to make sure I get the measurements right for the size I want. Whew! Who knew that furniture needed so much math? Can you think of any other real-world examples that use these unit concepts? You are going to learn so much in this unit. So as you're working, be sure to keep checking in with the visual reference guide found in your wrap-up lessons to go over the key terms, formulas, rules, and equations that you need to succeed. As you learn more and more about all this stuff, you'll start to see it in the real world too. That's pretty radical. See what I did there? And when you do, be sure to share that knowledge with your friends and family so that they don't end up like me, a guy with an oversized TV and a lot of redecorating to do. Speaking of, I should probably go get started on that. I'll see you all next time. Hey.